This Unreal Engine 5.5 scene uses one shared base material, but 4 independent dynamic material instances. The 3 small spheres remain red, green, and blue. The large runtime sphere changes from red to green to blue by updating one vector parameter named color. Its material object is created once, cached, and reused. In this lesson, we will explain why changing the shared base material is the wrong level of ownership. Create a UMaterialInstanceDynamic from a mesh component, cache the return pointer, set a vector parameter at runtime. Keep multiple objects independent, drive the sequence with timers, and verify exact parameter values, application count, instance count, and final color with automation, logs, and native Unreal frames. A material asset is commonly shared by many components. Treat it as the reusable recipe, shader graph, parameters, textures, and defaults. If one gameplay object needs a different runtime color, that state should not be written into the shared asset. A material instance keeps the parent shader structure while supplying per instance parameter values. A dynamic material instance is the runtime form that C++ can modify. In this demo, all 4 spheres begin from engine basic shape material, but each mesh receives its own dynamic instance. That is why changing the large sphere never changes the 3 reference spheres. In Begin Play, the central static mesh component calls CreateDynamicMaterialInstance for material slot 0. Unreal creates a UMaterialInstanceDynamic whose parent is the material already assigned to that slot, installs it on the component, and returns the object pointer. Always check the pointer before using it. A missing slot or invalid parent material can leave no writable instance. The reference spheres call the same helper, producing 3 more objects. The runtime log confirms 4 dynamic instances, all derived from the same basic shape material. The returned dynamic material is stored in a transient uProperty pointer named central material. Each colored change reuses that same object. Do not create a new dynamic material instance every tick or every time a value changes. That would allocate unnecessary objects, reset other parameters, and make ownership harder to reason about. Caching also gives the Unreal garbage collector a clear reference. The mesh component itself owns the installed material, but an explicit uProperty keeps the C++ relationship visible and safe. Create at initialization, validate once, then update parameters through the cached pointer. Apply color step maps step 0 to red, 1 to green, and 2 to blue. The selected F linear color is sent to SetVectorParameterValue with the exact name color. The same value also drives the point light and the readable state label, so the scene, log, and material parameter stay aligned. Parameter names are contracts. If the parent material does not expose a matching vector parameter, the call cannot produce the intended visual change. For frequently updated systems, cache parameter indices or use a deliberate parameter naming convention. For this beginner example, the named setter keeps the intent easy to read. The 3 small spheres prove instance independence. MIDA stays red, MIDB stays green, and MIDC stays blue during the entire run. The central sphere is a 4th instance that moves through the same 3 values. All 4 share one parent shader, but each stores its own color override. This pattern scales to team colors, damage flashes, selection highlights, dissolves, progress fills, emissive pulses, and environment state. If thousands of objects need the same global value, a material parameter collection may be more appropriate. Use a dynamic instance when the value belongs to a specific component or small group of components. These are genuine game mode frames from the included Unreal project. The first shows the central sphere in red with apply 1 of 3. The second shows green with apply 2 of 3. The third shows blue with apply 3 of 3. The 3 smaller material instances remain unchanged in every frame. The images were captured by Unreal through a scene capture component 2D and texture render target. They are not generated stand-ins. Color, label, application count, reference objects, and runtime logs all describe the same sequence. The Unreal automation test passed with 1 success and 0 failures. It verifies negative and overflow step wrapping, the red, green, and blue names, all 3 exact F-linear color values, the default 1.8 second interval, the initial step, and the class default application count. The runtime then proves the integration, basic shape material as the parent, color as the parameter, 4 dynamic instances, 3 timed applications, 3 native captures, final blue, and valid true. Pure tests cannot prove a shader changed on screen. A screenshot alone cannot prove edge case math. Together they provide a useful regression boundary. The reusable pattern has 4 steps. Create a dynamic material instance for the correct mesh slot. Cache the returned uProperty pointer. Set a parameter whose name and type match the parent material. Verify the visual result and the runtime state. Use scalar parameters for single numbers, vector parameters for colors and 4-component values, and texture parameters for runtime texture selection. Avoid recreating instances during frequent updates. Separate per-object dynamic instances from global parameter collections. With those ownership rules, AI-generated C++ can safely build a large class of responsive Unreal visual effects.